Okay, hello my friends and welcome to 711 Sampling Distributions. So, we have a fake scenario where there are only 4 people taking the Chapter 4 test. First, we are going to make a dot plot of our distribution. Now, I have never used this little draw on the computer thing before, so here we go. Okay. Here's my dot plot. And we've got 60, 70, 80, and 90. And we have one score at each. This is looking very nice and uniform. Okay, so now we're going to take a sample of any random scores and find the mean, which you don't need to pick the same 2 that I do. You absolutely can pick whichever ones you want. So I'm going to say that my sample is the 70 and the 90, which means that my mean, I'm going to use the same symbol that's on the calculator, would be, okay, 70 plus 90 is 180. No, it's not. It's 160 divided by 2 is 80. Now I want to come up with, oops, wrong way. I want to come up with all of my possible samples of size 2. So you can use your calculator to figure out how many there are, but I'm going to jump right into it by hand. So I'm going to start with the 60. So I could have a 60 and a 70, which means my mean would be 65. Then I could have a 60 and an 80, which means my mean would be 70. A 60 and a 90, which means my mean would be 150, so 75. And then I've got 70 and 80, which means my mean would be 75. Oops, I forgot my symbol. Squeeze that guy right in there. Okay. I've got a 70 and a 90, which means my mean would be 80. And I've got, I guess, 80 and 90 is my last one, which means my mean would be 85. Okay, so now my next dot plot is the dot plot of this sample means. Okay, so my lowest mean is 65 and my highest mean is 85. So I'm going to make the same x-axis as I did before. Okay, so I have a 65, I have a 70, I have a 75, I have another 75, I have an 80, and I have an 85. This is starting to look kind of normally distributed. So this is telling me that I had this dot here means that I had one sample. Remember, I took 1, 2, 3, 4, 5, 6 different samples with 2 scores each. I had one sample with a mean of 85. That's what that particular dot is telling me. That's different from the dot up above. My dot up above, this dot meant one score of 90. This means one mean of 85. So the mean of my population, well, my population was just those scores. So to find the mean of my population, I'm going to say, okay, I'm going to do 60 plus 70 plus 80 plus 90, all divided by, well, there are 4 scores, which is going to give me 85. Nope, why did I draw a 7? Nope, oh my god, why did I say 85? Apparently Mondays are still true even when there's no children here. Okay, 60 plus 70 plus 80 plus 90, all divided by 4, is a mean of 75. That's my population mean. And this guy gets the symbol mu. So we have some important ideas that come with this setup. And so I'm going to scroll over here so we can write them out. So my important ideas. For you, this is on the next page. The first one is the difference between a parameter and a statistic. Okay, a parameter is a number that describes a population. And that's going to be everyone. In our case, using all the scores. A statistic is a number that describes a sample. So the sample represents the population. My arrow got a little bit. Okay. This is a number that describes a sample. And the sample is supposed to represent the population. And we know from previous units that my sample is not always perfect. That's okay, we do what we can. So our different symbols, the symbols for mean, the symbol for our proportion, or the probability ratio, and the symbols for standard deviation are all different. Here we go. Are all different for the population and the parameter and the sample and the statistic. Okay. Okay. So for mean, our population mean, which is a parameter, is the Greek letter mu. Oops, that wasn't a very good one, was it? Let me try that again. That's better. And our sample is the X with the line over the top. Okay, that was even worse. Let's try this again. I'm also going to try to find a better platform, but I wanted to get started right away. So hopefully I should be better at drawing things. Then for the proportion, for the population, it's just P. So the proportion of the proportion of students at Bryan Station who are seniors is something like 250 out of 1,000. And then for a statistic, so this is out of a particular sample, it's, oops, I gotta stop hitting that button. It is a P with a wiggly line over the top. This means it's talking about the whole population. That's not a good P. Try this. Here we go. Yeah, okay. Then for my standard deviation, I've got my 0 with a tail, and for the sample, it's just the letter S. So those are my symbols. Okay, now, one last important idea. What we did today was we looked at different sample distributions. You might also see it written as sampling distributions. Okay, so the purpose of this is to show all possible, oops, okay, hold on, I forgot a word. The purpose of the sample or sampling distributions is to show the statistic, whichever one we're looking at, show the statistic found in all possible samples. So what we did today was look at the mean for all possible samples of size n. For us it was 2. So we made up all the possible combinations of scores for having 2 scores. And then we found the mean for all of them. Then we made a dot plot. In real life, you don't only have 4 scores, you have lots of them. So you end up with a sampling distribution with lots, and lots of dots. And it might be standard deviation, it might be, whatever. We did mean. Mean is probably the most common. And each one of those dots is going to represent that statistic for one sample. This is different from a population distribution, because a population distribution is going to show everybody. And that is 7.1.